Hi everyone. So today we're going to talk about the question insert into a sorted doubly linked list. Okay, so this will be my first question under the series of doubly linked list. Let's begin. Now for people who do not know what a double linked list is, a double linked list is nothing but it's actually a linked list in which you have two memory references. One is your next pointer, right? And you also have a reference to the previous pointer, which you can usually call it as previous. And along with that, you will have some data in this node, right? If it is a single linked list, what we have is you have a data and you have only one next pointer, which is basically one memory reference. As you can see, the word single in a single linked list is because there is one memory reference, right, in the nodes of the linked list. The word double linked list is because you have two memory reference in that node or in that object of the node class. Okay, so now what we are given here is with that introduction, let's understand the question. So this question is a very standard question. You can find this question on Geeks for Geeks, or you can also find this question on LeetCode. A lot of places this question is there. So what the question says is that you have a double linked list already given, which is sorted. Like for example, we take for example this 2, okay, 4, all right, then you have 6, okay. If in case you do not understand how memory references work, you can check out my video about a linked list, like reversing a single linked list using iterative version. In that I have explained in depth how memory references work. All right, so we have a a pointer to the start of the double linked list, right, as it is given. As you can see, the double linked list here is sorted, as in the data which is there is in a sorted form, sorted order. Right now we have your ascending order. Now they are asking us that whatever they're going to give you some data to insert in this linked list. Let's say they give you to insert a value as 5. Okay, now this 5 node needs to be inserted in such a manner that after you insert this data 5 in this linked list, the linked list should be sorted. That means 5 needs to be inserted in between node 4 and node number 6. Okay, so that the sorted order of the linked list has been preserved. That's what the question is all about. Now, this question is actually a very easy question, right? But the only difficulty which students or you will find is only because in a double linked list, you have a lot of pointer references to play with, right? If in case you miss out any one, manipulation in the pointer reference, or you make any mistake in one pointer manipulation, everything goes for a toss. So let's, understand how to solve such questions step by step. Okay, if you have to insert any data, okay, in this double linked list, tell me what are the scenarios where all you can insert the data. You can insert data might be at the start of a linked list. Okay, is it possible? Yes. If I give you to insert data whose value is equal to 1, or any value which is less than or equal to 2 will be inserted at the start of the linked list. That is case number 1. Case number 2 would be when you have data which can be inserted in between the linked list. Like for example, if you have data equal to 5, you will be inserting it between 4 and 6. And the last case would be, as you must have guessed, will be case 3, where you would be inserting data at the end of the linked list. Like for example, if I give data equal to 8, that needs to be inserted after 6 in order to maintain the sorted order of the double linked list, right? So now starting with this problem, we had divided this problem into 3 cases. There are 3 different scenarios which is possible when you're inserting the data. Based on which case you're trying to solve, your code or your pointer manipulations are going to slightly change. Okay, so let's start with the easiest one, which is the case 1. Okay, how do you identify that a particular data which needs to be inserted is in the case 1? It's very simple, right? If let's say you have this data stored in a let's say value as 1, okay, you're going to create a new node out of it, right? Because let's say this particular double linked list node is present in a class called DLL, right? So you're going to create DLL new node equal to new DLL, and you're going to pass in the data, let's say 1. Right? How do you know it is first? Because if head dot data, if this value is greater than or equal to your new node dot data, then obviously you are going to fall in which case? The first case. Okay. If this is the case, how will you actually achieve this? Let's take an example and check. So let's me write down this linked list. You have 2, you have 4, right? And we have 6. All right, so this is going to where my head is going to point to. So I have a new node here, which is 1, which I need to insert, and this has a value as new node. This is a memory reference which is pointing to that data. Currently, the previous and the next of new node both are basically equal to null, right? So what is the first thing I would have to do? Now this is going to be my first, node in the linked list. That means the first step which I would have to do is new node dot next should point to where? Head. That means I'm making a connection. Let me write it here. It might be easier to visualize. Suppose we had here, so let me write here 1. Okay, and let me call this as new node. Okay, so the first thing I'm doing is new node dot next equal to head. That means new nodes dot next is pointing to what? Head. Correct. After this, because it's a doubly linked list, we also have to make sure that head's previous is now pointing to new node, right? Because initially head's previous was pointing to null. Now it has to point to what? New node. So I'm going to do head dot previous equal to new node. Second step is going to establish this line, right? So now we have added this node, this new node into our doubly linked list. What is the last step remaining? Because it has been added at the start, we have to make sure that we update our head of the linked list to this new node. So head is now going to point to new node. So you have now head which is pointing to new node. So this is our case 1. So when was our case 1? Just to recap, whenever the head.data or the data which was present in the first node of a doubly linked list, if that data is greater than or even equal to the new data which you're trying to add, you will have to add it at the start of the doubly linked list, right? And you just need these 3 manipulations and your job is done. Okay, so this is the simplest case. Now let's talk about case number 2, when you, let's say, had to insert data in between. Let's talk about this case only where we want to insert number 5 inside, inside this doubly linked list. So let's go down. Let's draw this linked list again. I would have, suppose 2. Okay, here we had 4 and here we had 6. Okay, so you have this next and previous, right? And let's say we created this new node because now we want to insert the data which has value 5. So let's say I created a new node for this. Okay, and what you let's say this is your head of your linked list. Let's say we traversed and we have a reference current which is pointing currently to this node 4. Okay, because now we want to insert this node 5 between 4 and 6. So we made sure that we have a reference point, that we traverse the node from the head of the linked list and we made sure that we are stopping at this node number 4. We'll come to it later on how we traverse and what condition we should use. Let's first understand the different pointer manipulations you will have to do, okay, to accommodate this number 5 in between the 4 and 6. Correct? Now right now the previous and the next and previous for this particular new node is null. Correct? Now, can I write the first step? Let me write the first step. First step I'm going to do is new node. I'm going to establish a connection between 5 and 6. Basically, I want to establish that after node 5, the node number 6 should come. So I'm going to write new node dot next equal to current dot next. Can I do that? Yes. What will current dot next take you to? Current dot next is actually pointing to this particular DLL node, your doubly linked list node. You are saying wherever your current dot next is pointing to, make sure your new node dot next is also pointing to that particular memory reference. So we did that. So we are basically going to have new node dot next is pointing to your current dot next. So we have just able to add this one memory reference manipulation. Next is I want to make sure that 6 previous, if you can look at this, the previous node of 6, right? If I had to insert 5 in between, then the previous pointer of 6 should point where? To your node number 5. Currently, it is pointing to where? 4. That means I need to manipulate this and make sure now it is pointing to this new node, right? So let's do that. So the second step I'm going to do, how would you get hold of this 6? If you're standing at new node, or you can even take it from, there are 2 ways of reaching node 6. One is, let's say, basically from your current you could reach 6. How could you reach 6? You could say current dot next, or the other way is you could also say new node dot next, right? So we have two ways in reaching next. You can choose whichever one you are comfortable with. Right now I'm going to choose this one. I'm going to say current dot next. What I want to basically, manipulate, I want to make the previous node of this node number 6 to point to 5. So current dot next is going to point to the node number 6. I want to basically manipulate the previous pointer. So current dot next dot previous should point to new node. So now what is going to happen is this will get, change, and this will now point to new node. Did you understand? Let's go through it once again. What I said is I wanted to make sure that this node number 6 should now, its previous value should now point to 5 because I'm inserting the node number 5 between 4 and 6. Initially it was pointing to 4. Okay, so what I did is to reach, I have to make sure that this node's previous needs to point to node number 5. So what I did is I could say current dot next, which is going to give me this memory location. The previous of this object needs to point where? New node. This was one way of doing it, which I have shown here. Or else you could also do, because you have new node and new node's next is pointing to 6, there's already a connection. You could also say new node dot next. Okay, new node dot next, that's previous. So new node dot next is nothing but 6, dot previous is nothing but is going to point to 1. So both the ways work here. Okay, I hope this made sense. So we have now, established connections here. Now what is remaining? If you think about this, what is remaining? We just have to, update this pointer. This current dot next should now point to new node, right? And new node's previous should point to 4. So we just are left with 2 more steps, right? So let's write the third step. There's a third step which we're going to do. Current dot next is now going to point to new node. Can you see? Current dot next is going to point to new node. So that means I'm going to manipulate this pointer, and my new updated part is current dot next is going to point to new node. Okay, what is next last step remaining? I just have to make sure new node dot previous should point to current. So new node dot previous is going to point to current. So if you look at a doubly linked list in any kind of question, right, you will always have to take care of 4 pointers, right? Because if you're inserting in between, there are 4 pointers, right? Why 4 pointers? For every node, you will have a next and previous, right? So with this and this node, you have to take care of 2 pointers. With this and the previous node, you have to take care of 2 pointers. Total, there are 4 pointers, right? If it's a single linked list, you only had to manipulate might be 2 pointers, right? I hope this is clear. So whenever there's a single linked list or even a double linked list question, it is always advisable to take a paper pencil and draw out the scenario and check what exactly is happening, right? Because otherwise, if you, even if you, let's say, change the order of this, manipulations, it is quite possible that you might run into a null pointer exceptions, or you might have an incorrect manipulation done, right? So it's very important that you just write on paper pencil, just work out what is exactly happening, right? And you will never make any mistakes. Okay, so that means this particular 4 steps are going to work for all the cases whenever I have to insert a node in between the linked list. Yes, is it clear? I hope it is. Now let's go to the last part. The last part of our particular case was when if we had to insert at the end of the linked list, where we were supposed to insert data equal to 8. So let's keep this. Let's say I'm going to put here, let me have 2. Okay, let me have 4. And then I had 6, and now I want to insert 8 here. So I'm going to write 8 here because this is a new node which I want to insert. This is my linked list, right? And this is where my head is pointing to, and this is the new node which I am worried about. Okay, now let me try to use this 4 steps which we had used for case number 2. Yes, we had used this for case number 2. Let's try to use this 4 steps for the scenario where we're trying to solve, where you want to insert this new node for what? For at the end of the linked list. Let's see, can we reuse those steps? Okay, so the first step we had done is we said new node dot next. So let's say this is your current node, because now you want to insert the node after 6. So that's why your current will be pointing to the 6th node. So your current node is nothing but that node. We are going to make sure we're going to write another piece of code where we are going to traverse from the start of the linked list and going to stop at the current node. That current node will be such that after that current node we want to insert this new node. Okay, so right now current is going to point to the end of the linked list because we want to insert this new node at the end of the linked list. Okay, so I'm going to say new node dot next is equal to current dot next. Tell me right now, where is current dot next pointing to? It is pointing to null because it's the last node of your double linked list. So what I'm saying is new node dot next should also point to wherever current dot next is pointing to. What is current dot next pointing to? Null. So you are saying whatever current dot next is pointing to, make sure your new node is also pointing to the same thing. So let's say this is, I'm going to make sure I'm going to point this to null. Correct? So I have done with my first step. Correct? Next is I'm saying current dot next dot previous. Now what is current dot next? Current dot next is nothing but null. Can I say null dot previous? In my second step, current dot next. In my scenario here, case number 3, current dot next is nothing but null. If I use this step, null dot previous is going to give me a null pointer exception because null dot previous makes no sense at all. That means that I cannot use step number 2. So let me just make a note of this, that this particular step does not work or is not needed. Okay, let me write it that way. It's not needed, right? Because we do not have any node after the last node, right? So this is not needed. For what case? For my case number 3. So step number 2 is not needed for the your case number 3. Let's move on to the third step. Let's see whether we need this step 3. Step 3 say current dot next equal to new node. Fine. Current dot next is right now pointing to null. We want it to point to 8. Yes, makes sense because now we want to, include 8 as a part of our double linked list. So there should be a connection between 6 and 8. So this makes perfect sense. So I'm going to say here, current dot next equal to new node, which is what we did in step number 3. What is step number 4? Step number 4 is saying new node dot previous should point to current. Yes, new node, right? New node's previous is pointing to nothing, and we should make sure that it has to point to the previous node, which is right now the current node. Okay, so we did require 1, 3, and 4th. Only the step number 2 from our previous solution was not required for the case 3, where we are adding at the end. Now tell me, when you write this code, all right, how will you write this code for this question? If you've understood all 3 cases, you would say simply there'll be first if condition would be required, where you will be saying that whatever data, new data, whichever you're trying to, add, if this new data is less than, right, or is equal to the head dot data, what is the case you are referring to? You are referring to case 1. So can you write the code? In case 1, we wrote this particular code, right? Where is this? We just had 3 steps, right? Can you see this? Only this 3 steps needs to be added in the if condition. Yes, absolutely. Correct. That's what we need to do. What is the second case? The second case is, can I now club case number 2 and case number 3 into one else part? Yes, absolutely, I can do that. What I'm saying is my else part will basically be those cases, case 2 where I'm inserting in between and case 3 where I'm inserting the node at the end of the linked list. Why I can do so is, in my last case, which is the case when I'm adding the linked list node at the end of the linked list, I just do not want this step number 2. How can I ensure I do not execute this if it is the last node? I can simply put a condition for this particular case. Let me use a different color. I can simply put a condition here before executing if current dot next is not equal to null. Right? It makes perfect sense. The reason we did not execute step number 2 for case 3 because our current dot next dot previous did not exist. I mean, current dot next was null, so I couldn't have null dot previous, right? That means if current dot next is equal to null, please skip this step. But if it is not equal to null, that means you're lying in case number 2 and you can execute this step. That means I can combine my case 2 and case 3 into one code, and that will be in my else part. Right? So this is how, you actually work out the logic. So trust me, if you really had just looked at the question and you had started coding, that is not the way how you solve problems. Always, even writing code should be the last thing you should do. First, take a paper pencil, work out the solution, see different scenarios for which, and make sure whether your code, whatever logic you are trying to come up with, works for different scenarios. Like in this situation where I had the question of inserting into a sorted doubly linked list, I cannot have any more scenarios, right? There will only be 3 scenarios. I can only insert in between the linked list, at the end of the linked list, or at the start of a linked list, and have taken care of all 3 cases. Might be there is one case which I can think of. That one case would be If let's say the head, that means if your linked list was completely empty, if your linked list was completely empty and the data which you're trying to insert is the first data you're trying to insert, in that case might be I can even have one more if condition here in my code, might be before this also, even before I do data is less than or equal to head dot data, might be I can actually write a code here saying that if your head is equal to null, that means if it's an empty linked list, just simply return the new node as your linked list head, right? So this is one more case which is possible, right? Other than that, I cannot have any other scenarios. I hope this makes sense, right? And if you look at the time complexity, this is actually, if you look at the time complexity here would be O of n. And the reason is because we have just looked at the manipulations required for adding the node into the linked list. But there is something which we have not taken into consideration is basically I will have to start my current from head and then I have to identify the node after which I can insert my data. Now this is going to take you in worst case O of n time, because might be you want to insert the node at the end of the linked list, which might be the case 3. Right? And if it's in a linked list, that means traversal needs to happen. You have to visit each and every node. Now let's look at that. How do you identify this current node? How do you know after which node you have to, basically put up your data? That will be very easy, right? Think about this. Let's take, we have 1, and what we had, say 2, 4, and 6. Okay, let me just write simple, and let's say you want to insert the data 5. Okay, what is it? 2 is less than, right, or equal to 5? Yes, correct. So I can move on. I can say this is my current. Initially, let's say my current was here, and now my current is here. Now, what is here? Is 4 less than or equal to 5? Yes, it is. Can I move on? Yes. Does this work? No, this is not working. Why did we go wrong? What happened? I was actually checking at current dot data. I was checking data of current dot data less than or equal to the data which I wanted to insert. This is what I was looking at. And because of which what happened is by the time I reached, by the time this condition is met, I have reached node number 6, but I had to stop one node before that. Why? Because if I stopped one node before that, then only I will have, be able to, it will be easier for me to insert the data here, right? I'm not saying you cannot insert the data, if you stay at the end. I'm not saying it's not possible, but then might be if you go with this step, you will have to be sure that might be, let's say if you had to insert 8, right? Your current would then stop at the null, and then you would not have any access to the previous data, right? So it's better that you stop one node before it where you had to insert. Now, how do I do that? Can I say current dot next dot data? If current dot next dot data is less than the data which I'm trying to, basically insert, then is where I'm going to, while current dot next dot data is less than or equal to less than data, then I'm going to say current equal to current dot next. Will this work? Let's try it on the same thing. So I'm going to draw it here again. So we had, I think, 2, 4, and 6, right? So we're going to say 2, 4, right? And 6. Let's say I want to insert 5. So what I'm going to say is, we're standing here. When you're standing here, you're trying to check for the next data. You're basically trying to check beforehand, should I even go hop to the next one? So how we're going to do that is current dot next data is nothing but 4, right? So is 4 less than or less than 5? Yes, it's the case. Can I move ahead? Yes. Okay, what about this? When you're standing here, what is the next data? 6. So is 6 basically less than 5? No. That means you should not hop, right? And this was basically the mistake we were doing in the previous case, right? We were actually checking the data where we are currently standing at, right? And then what was happening is you were taking a hop, and might be it was the last node, and then might be you'll just get, lose the reference to the previous data. So instead of that, what we can do is we can think ahead. We are standing here and let's try to look at, our next data. It means we're making a decision. Should I at least, make a hop? Should I go from here to here? Before even I hop, I'm making a decision. Okay, so I'm standing here and I'm saying, should I make a hop to this 4 data? How do I make a decision? I'm asking whether current dot next dot data, is it less than the data I'm trying to say? If it is less, then yes, obviously I have to go, because I cannot insert 5 here, right? That makes sense. If, let's say if I had to insert even say, any value, like after 6 also, let's say I had to insert 7, right? So what is going to happen? Then this condition is going to true and you're going to come here, because now your data, what is it? Current next dot data 6 is less than 7, so you can hop, right? So it does even work for the situation in the case 3 where you are inserting at the end. correct? Because now you will have, there's no current dot next, correct? Is there any current dot next? No, there's none. That means in this while loop, I also have to make sure, check that current dot next is never equal to null. All right, I hope this is making sense, right? If you've understood this, then let's try go to our IntelliJ and try to code for this particular scenarios, right? So here I have, I just created a class. I have a static, just to return the head of this newly inserted, node, and I have just made it, I have a linked list. Okay, so let's say I have a class here, DLL, which has this data, right? It has this next and previous pointers, right? And I have this new node. So let's assume that, that data, whichever data I needs to add is already been, a node is created out of it, and that is given to you in the form of new DLL node. The only job is to make sure to insert this new DLL node in its correct position in the DLL sorted linked list. Okay, so what's the first situation we'll do? The first thing we're going to do is, let's check if your head is equal to null. Let's simply return the value of new DLL, right, node, right? Because we're saying it's the first time you're inserting the node into the linked list. Let's just simply return it, right? This is the first case. What is the next case? Let me write else if. Okay, what if whatever data, let's say new DLL node data, right, dot data, if this value, okay, if this value is less than or equal to the head dot data, or in other words, the data which is present at the start of the linked list, if that value is greater than, okay, the data which you are trying to insert, then it means you're going to insert at the start of the linked list. That means you are here referring to case number 1, if you insert at the start. If you're inserting at the start, what we have to do is the only 3 manipulations which we did, right? So you said new DLL node dot next should now point to your head, right? Head dot previous should point to this new node, correct? And we have to make sure that, we have to return what, this new node as the start of the linked list, right? So it's originally returning from here. What is the next case? Now remaining cases is, we said we would code case 2 and case 3 in, one else flag. Basically, if you're trying to insert the new node in between or at the end, we are going to take care by, this step, right? So in this case, we had, basically 4 steps. Let's go one by one. The first thing is new DLL dot next, right, is going to be your current dot next. Now, even before that, I have to write a while loop, right? So let's write a while loop, because how will I get my current? Agreed? So how will I get your current? Let's say I'll have, your DLL node. Okay, so let's say DLL node current. All right, so this is, I think, DLL. This is of the class DLL. So you have current equal to head. So basically it has to point of head, right? What I next want is while current dot next is not equal to null, right? And what I'm saying is basically current dot next, right? Let's short it up. It's a big word. Current, let's have current here, let's have current. Okay, so current dot next dot data. Okay, current dot next dot data, if it is less than your new node DLL dot data. If this is the case, let's keep on, current equal to current dot next. Okay, but when you come out of the while loop, you're basically pointing to that current after which your new node needs to be inserted, right? So I'm going to say here, I'm going to do the step of manipulation. So new node dot next equal to current dot next. That's your step number 1. Step number 2 is current dot next dot previous is nothing going to point to new node. Okay, so we are going to even create it. Okay, their name is new node here, right? What is the third step? In the third step, we have to make sure that as third step was this, which was basically current dot next dot previous should be pointing to new node, right? So to make sure of this, we have to be very sure that current dot next should not be null. So if current dot next is not equal to null, then only you have to perform this step. So this is going to take care of what step? Your case number 3. If in case it is null, that means it's case 3 and you're going to skip this part, right? What is the last step? The last step is that new node dot previous should actually point to current. So we have taken care of all the 4 pointers. And at the end, just make sure to return your value, which is the start of your linked list. Okay, so this is, I think we have written the entire code. Now let's try to see if we can run this code. So I already have so this is like one of the site where they had this question. So this is insertion and sorted doubly linked list, right? So whatever code I just wrote on IntelliJ, I've just copy pasted here, right? So they had already written the boilerplate code. And if I actually run this, it actually, works for all the scenarios, right? Yeah, I'm so sorry. It just got this. So yeah, it works for all the scenarios, right? So the 6 test cases and it works fine for all the cases, right? Same code, just I have, if you can see this if condition is there, else if is here, and else part is when you want, those two cases, case 2 and case 3, which we spoke about, right? I hope this helps. Make sure you practice a lot of questions around, doubly linked list. They're really fun to work with. Just, the only trick is that just take a paper pencil and, try to work out different scenarios on paper pencil. Take, literally, like, might be take different colorful pens and try to see what are the different manipulations you're doing. What are, when you do a manipulation, like when you kind of write one line here, right? New DLL node dot next equal to head. When you're doing this memory references, manipulating the memory references, just try to understand what is actually happening behind the scenes so that you do not make up any mistake, right? Because if you, in case, do not do this manipulations correctly, then it is quite possible that you would, end up into a memory leak or a time limit exceedation. Okay, I hope this helps. Bye.